Hi everyone, welcome back. Let's see one of the question on semaphores concept. Let's read the question. What is the maximum number of processes in the critical section for the processes Pi, where I means I equal to 1 to 10 processes for the following program? Means what they are asking, if I have a critical section like that, critical section, how many number of maximum processes can able to reside in the critical section, and how many processes are there outside waiting are P1 to P10, means P1, P2, P3, P4, P5, P6, P7, P8, P9 and P10 are the processors waiting outside in the ready queue. Now how many processes will be there in the critical section? That is what the question is, right? And they have clearly mentioned here the mutex as 1. Mutex as 1 means it is a kind of binary semaphore, right? So let us try to give chance to P1 first. Assume P1 got the chance. When P1 got the chance, P1 to P9 process are going to be executed this code, and P10 is the process which is executing this particular code, guys. Now if P1 got the chance, P1 will execute P of mutex. What is P, guys? In the earlier videos I have clearly mentioned P means down operation, V means up operation. P means what? I am going to decrement its value by 1. That means mutex value is now 0, right? When the mutex value is 0, it will decrement it. Can it enter into the critical section? Yes. P1 enter into the critical section. Yes, good. Now while P1 is executing, does P2 allowed to execute? Just check with this one. P2 is executing. Does it allow? No, because P2 is trying to down the mutex. When trying to down the mutex, its value is -1. Does -1 is allowed to enter into the critical section? No, it couldn't possible. That's why P2 is going to be rejected here. So P2 will be rejected at this point of time as its value is -1. Suppose for example, instead of P2, if P10 got the chance, if P10 got the chance means other processes are trying to execute, what it is doing? It is performing up operation on the mutex, means it will perform increment by 1 and then it will enter into the critical section. So what will happen? Now P10 is going to be entered into the critical section. Now meanwhile, can somebody again P2 will enter into the critical section? Just think about it, right? P2 is trying to down the mutex operation, which means it will perform 0. When it's performing 0, yes, it will be allowed. So P2 also will be entered into the critical section. Now suppose for example P3 wants to enter. Does P3 allow? Just check. Is 0 -1? -1. Does it allow? No. P3 is rejected. But suppose for example P10 is already here. If it wants to come out from this critical section, then it will execute this point. What I have written here? Up of mutex means again this will made as 1, not -1, guys, because it is not successfully done, right? This will made as 1. When it is made as 1, now P3 allowed to execute? Yes, it will decrement by 1, that is 0. So P3 allowed to execute. Then can the process P4 allowed to execute? No, because it is -1. But if suppose for example P10 wants to enter again, P10 perform up operation, yes, 1, then P10 done. Now P4 can enter? Yes, because it will decrement its value by 0, allowed. Now P4 enter into the critical section, done, right? So far P10 is exited first time, now second time is entered, right? Now again P4 wants to comes out. When P4 wants to comes out, it will again increment by 1 because of the code. Am I right? Now P5 is allowed? Yes, by decrementing its value as 0. Then can P6 allowed? No, because its value is -1, so it is not allowed. Now P10 will try to enter into again, right? So here you have to think this is not P4, it's mistakenly cross mark. P4 is there, P10 wants to come out, P4 allowed, then P10 is entered. When P10 is entered, it will increment its value by 1. Good. Now P6 allowed, yes, P6 allowed by decrementing its value. Now P6 is in the critical section. Guys, hope you understood analysis so far. Let me complete it. Now P7 wants to enter into the critical section. It will not be allowed because of -1. But if P10 wants to come out, yes, it will increment its value by 1, and then P10 comes out. Now does P7 allowed? Yes, P7 is allowed. So P7 is into the critical section by decrementing its value as 0. Now can allow P8? No. So it will increment its value by 1 and enter by P10. Done. Now P8 wants to enter into critical section. Yes, it will done by decrementing its value 0. Happened, and it will enter happily. Now P9 allowed? No. But if P10 wants to comes out, it increments its value. Yes, it comes out. Then can allow the P9? Yes, by decrementing its value as 0. Now P10. Now try to observe. P9 is entered. Now P10 is entered. Yes, by incrementing its value 1, P10 is entered. Right? Does all the process completed? Yes. Guys, if you are able to observe at this point of time, how many processes are there in the critical section? P1, P2, P3, P4, P5 is entered, guys. We missed P6, P7, P8, P9, P10. All the processes are entered into the critical section at the point. So maximum number of processes which might be there in the critical section will be 10. Might be there in the 10, right? So this is the answer for the given question. So what they have missed the logic here, instead of writing here as V of mutex, they have to write as P of mutex, so that at any point of time only one process is going to be entered into the critical section. Because of this small mistake, all the processors are allowed into the critical section. Hope you understood this video clearly. Thank you.